welcome back to another professional prep video. In this video, we're going to be discussing a theorem in calculus known as the intermediate value theorem, or IVT for short. So, let me first, before I get into what this theorem states, let me talk about what the conditions for the theorem are. So this theorem is talked a lot on an interval, A to B, and it has to be a closed interval, by the way. So in order to actually apply this theorem, f needs to be continuous. And let's let f be that function that we're talking about. F needs to be continuous on AB. And that's a closed interval. So we use brackets instead of parentheses. So if f is continuous on this closed interval AB, we can apply the theorem. And the theorem states that, let me do an example in order to prove what the theorem states. So let's let this be an example. And alright, so let's say we have a function f, and f is continuous on the closed interval -3 to 3. And we want to try to figure out what we can, which of the following, A or B, we can conclude based off of that. But we need more information to use the intermediate value theorem. So we have to be given the bounds. So we don't necessarily have to be given the bounds, but very often you'll see that you're given the bounds rather than a point inside of that interval. So say f of -3 is going to be -7. F of 3, let's let that be 4. And f is continuous on -3 to 3. So which of the following can we conclude? There is a value c for which f of c equals 0, and -3 is less than c is less than 3, or f of c equals -8 on that same interval for c. So I feel like this theorem is very self-intuitive. Now that I'm about to explain it with an example, it'll make a lot of sense, because I don't really want to use complex mathematical notation per se in this video, because it will probably just confuse a lot of people, which is perfectly fine. But let me explain it through an example, and it'll probably make a lot more sense. So the answer here is A, and I'm going to explain why that is. So the reason that our answer here is going to be answer choice A and not B is because of this 0 versus this -8, which you might have concluded. But essentially, f is continuous on -3 to 3, and the bounds, -3 is -7 and 3 is 4. So that value, the function has to hit the value 0 at some point on the interval -3 to 3 for x, or c in this case, because it's continuous, meaning that it'll hit the function will have the value of every single number between -7 and 4 at least once. So that's why it has to equal 0. And if you sort of think about it on a graph, say that, that was horrible, sorry, let me put it here. Say that this is our coordinate plane here, and say that we had f of -3 equals -7, let's let that be that point, and f of 3 equals 4. So the function's continuous, which means it's doing something like that. We don't know exactly what it's doing, obviously, but it has to be doing something like that. So this is -3 and this is 3. So no matter how you do this, since the function has to be continuous, the value of the function has to be 0 at some point. And you can see that too. Just look at this graph. This is -7, this is 4, And sure enough, the value, it's going to be 0 right here. And it actually has to hit, the function has to be equal to every value between -7 and 4. So -6, -5, somewhere there. But yeah, so like -6, -5, but on and on. The function has to take on each of these values at least once. There's no way that you can get from this point to that point without hitting the place where the function is equal to 0. And for that reason, it's going to be A. It's not B because we cannot assume that the function will hit -8 at some point, because it could. If you had something like that, it very easily could, but we're not given that it does that. That it goes down first. So that's why we cannot assume B. -8 is greater than -7, and it's on that same interval. So that's why B is wrong and A is right. But I hope that this video helps explain a very important theorem in calculus, the intermediate value theorem, and I will see you next video where we talk about derivative properties. So have a great day, everyone. Please feel free to reach out to us if you have any questions. Please subscribe to our channel and have a great day. Thank you.